Welcome to all the participants in the morning session of FDP, and it gives us immense pleasure to welcome Dr. Devendra Jha in this FDP session. He was born in Sarhad, Madhubani, Bihar, India. He received the BSc degree from BIT Sindri, India in 1987, the MA degree from Delhi College of Engineering, Delhi in 1993, both in electronics and communication engineering, and the PhD degree in fuzzy approaches in image analysis from the Department of Electrical Engineering, IIT Delhi in 2003. He joined DRDO as a scientist in 1989 after completing his fourth electronics fellowship course at IIT Pune, India, and after a brief stay in the fertilizer industry as an instrumentation engineer. He has worked as acoustic optic FH spread spectrum receivers and secure communication system analysis. Presently, he is working on a project which aims at analyzing satellite communication signal. Conference papers he has published in the Defense Science, Journal and Pattern Recognition Letters. His current research includes fuzzy pattern recognition, secure communication system design and analysis, cognition-based signals, and image processing, steganography, and biometry. He is also a member of IETE Delhi. So I request Dr. Devendra Jha to please take over the session, and sir, please enlighten us with your knowledgeable skills.
Thank you, Mrs. Kanika. Nice introduction.
Welcome, sir.
So I will
Thank you, sir.
let my slides to be shared. So I hope the transparency is visible at your end.
Yes, sir. Yes, sir. Visible.
Voice is also audible.
Yes, sir.
Yes, sir. Perfectly fine.
Good. So we'll go ahead. So just to add the introduction, see, we are working on the cybersecurity area, particularly to the application of Ministry of Defense. And then my basic background is in electronics and communication. Since the projects generally are multidisciplinary, so that's how I could also find place in this new upcoming domain. Okay, so we'll see. Probably my transparency has not been properly been. I will do it again. Slide sharing. Will that be all right if I move like this?
Yes, sir.
Yes, sir. Yes, sir. You can. You can
Then, fine. Fine. So see, this COVID has given a lot of lesson to us. So not only you are getting this something learning new, we are also learning many things new. Because first time I am delivering this lecture through the Zoom and all. So I am also learning very new things. Okay, we have attended meeting, of course, through this one, but yes, this is a new thing for me. So, so today's discussion, my agenda is we will first discuss about the trends of IP traffic, because we are doing the analysis of IP traffic. So, what is the trend? And we'll discuss the introduction of this thing, and then we'll focus mainly on the email, because we have kept our thing limited to the email. And we'll see that how open source tool, Wireshark, is very useful tool nowadays, and which can do the many analysis of purposes, solve analysis problems, network problems, all those things. Then we'll see how the packet capturing can be possible. And we'll discuss something about the satellite communications, because being in that field, so I would love to discuss certain thing in this area. And then we'll correlate how this, from how the traffic is coming from that, and how it is similar to the, how it fits into the OSI model of communications that we generally computer science people discuss in their first networking lectures. And then we'll see how we can we can analyze and reconstruct the emails using this Wireshark as open source tool, because that is the good thing to see. Then if we'll permit some time, then we'll discuss something about, of course, this is theoretical things, SMIME and PGP, and then we'll discuss some vulnerabilities. These things you are much converse with all those things, but then I will also like to add it to that. So what is the motivation behind the traffic analysis? So the first thing is, being the network administration, one would like to determine the problems in the network and troubleshoot all those things. Then one may also like to test some device. Then for that purposes, one has to generate traffic and report and how to do the network planning of a particular link. So for them also the traffic study and analysis is required. Then there is a lot of commercial applications. Commercial applications, because you know now there's marketing as well as billing, when everything is now getting connected over the net. So the analyst has to do all those things through the traffic analysis. And then for the law-abiding people, one has to also look into somebody is intruding their networks and hacking their contents. So there also these things are required, because one has to do the DOS, DDO, distributed hacking and attacks. Then the more important thing for the security and intelligence people are to know the traffic of the adversaries or the bad intention oriented people. For them, the adversary has to be analyzed. So this is where my focus is. Then we'll discuss part by part. So we'll first we'll see what is the trend of the internet traffic, because how internet traffic is growing by leaps and bounds over the years. So this graph, which is most of the transparency that I have taken is from the internet, so you can also find it. And so you can see this is the exponential graph. It is going over the last from 90 onwards. It is exponentially had increased. 3,000 million users has been connected, because we have 7,000 million people in our globe, and out of them 3,000 are connected with the internet. This is the data up to 2014. So the growth, one can see that the growth, particularly the Africa and the countries, they are poor countries, not having good infrastructure, but the growth has been order of 6,000 times percentage. That has been the growth. And see the number of users, you can see 87 or more than % in North America, USA and Canada is connected population with the internet. So see the type of connectivity that is there in the connectivity of the internet traffic. Then application wise, one can see that everything is now coming over the internet. So including the TV, then voice, video on demand, everything is going on internet. So you can see the content are expanding over the years. And the application that I have just taken and listed here, the cooperative editing, people sitting from one place to other place, work together. Then browsers are also well known. Then the network application, online gaming, shopping, banking, everything. The entertainment, voice, video on demand, voice over IP, IPTV, everything is going through the internet. Even the internet, we see that the portion we often call of the deep web. So it's analogous to the iceberg. The web that we are working, that is the content that is indexed, is only the tip of the iceberg. And most of the non-indexed thing, for example, banking and other things, are restricted one may not able to look into that. And of course, the dark webs are also coming, which are mainly peer-to-peer, not the client server, unlike the traditional things. So that is how the traffic is being exchanged over the internet. And one can see the type of protocol that has increased the flow. Earlier, the majority of the traffic were TCP, is a connection oriented. And though the number of bits and bytes and packets is still large, but they see the exponential growth of UDP traffic, particularly to the gaming and voice over IP and all those things. So earlier this percentage was very low, but now it is taking the majority of the space. So this is how this thing is growing. So you want to see port also distribution, how the TCP and UDP ports now taking place, and the ports that is assigned by the international IANA number assigning authority. That so they have the legality 1 to 1024 ports. They are assigned, and they cannot. They are reserved. They can be given through the assignment authority. The remaining port number, which is greater than 2024, and it is the major share, can be used by anybody. So this is how it has grown. And particularly to the UDP, the voice over IP, you will find majority of the ports are having the port number greater than 1024. So this is how the applications are exploding. Then similarly, the port usage and the proportion of internet applications. So this is how we can see. So this warrants the analysis of the IP traffic. So that is the motivation and introduction. Coming to the brief introduction about the email, though people must be aware of much in detail the email, because the email is nothing but we are exchanging the message through the digital media, and it allows us to store and forward the content, which can be accepted, forwarded, delivered, and stored in any point in between the connected networks. So the history goes back to the ARPANET, when it was initially extended through FDP. So the basic structure of the email it's just a letter. It has a body and the header, that is the address. So address contains simple information about who are the sender and who are the recipient and what is the subject. And the content is the text message. So it was restricted with the ASCII kind of coding mechanism, because only ASCII things could be sent over the network based on the initial request for RFC 822. Request for the RFC. Now, recently what we can see that how the actual email works. So suppose Alice and Bob are the transmitter and the recipient of a message information. So at the sender side, we have a user agent and message transfer agent. And they are connected, registered with the mail servers. So the mails, they will the user agent will allow the sender to formulate the message, and the message transfer agent with the peer message transfer at the server will accept the message over the LAN or WAN or any connected link through SMTP, simple mail transfer protocol. And between the two mail servers, also the SMTP protocol holds good, and it goes over the cloud of the internet, and then it will be stored at the recipient's mailbox. Now the recipient, as you wish, requires to extract or take see the mail again through the message access agent or message user agent. So the protocol used here is POP. Now it has been enhanced to IMAP. So we'll discuss something about these things. So this is the simplified diagram. Again, shown how the between where to where the SMTP and between where to where the POP and IMAP was placed. So one has to note that the between client and server, this is the communication goes through the command and response mode. So gives one request and other respond accordingly. So request and response mode, the clear client server architecture. In the SMTP, which is called Simple Mail Transfer Protocol, it's a part of application layer TCP/IP protocol suite, and it works on store and forward. The SMTP moves email on and across the network. SMTP used to send email from a local client to the recipient. Aside from the sending email, the protocol also acts as a safeguard to filter which passes through it. It regulates and limits how many messages and amount can be sent. So this is the another characteristic of the SMTP. It can also be used to regulate. The port number, which are commonly used, because this parameter is required for the traffic analyst. For plain message, 25 is the standard port which IANA has assigned it, and this is the standard the entire world knows. And for the encrypted kind of traffic, which goes through secure socket layer or the transport layer security ports, also known as SMTP, 465 number is used. Similarly, for the POP, the port number 110, and if it is plain, and 995, it is if it is encrypted. So what actually the POP allows is, it allows us to download the email, but the moment we download it, the message is removed from the server's inbox. So now the responsibility lies on on us or the recipient to manage the messages. The same thing has been improved into the IMAP, Internet Message Access Protocol. It allows us to look and fetch also, but at the same time, the message will be kept at the server side. So this is the advantage it has given over the IMAP. It uses port number 143 and 993 respectively for the plain and encrypted one. So the complete delivery structure, one can see that this is the sender, you can say Adam and Smith, which request. So there is the sender mail server, but the mail server has to know which is the email address where it has to be sent. For example, this is the Smith lies. So it has to be sent to smith@b.com. So this is being asked by the DNS servers. So the DNS fetches the IP addresses for this, and accordingly, this is routed through the network on those IP addresses. And similarly, once it comes POP 3 protocol. Now the limitation sending mail through is uses Hindi, or let's say some Chinese citizen uses their Chinese language or German languages. For them, it will be difficult to incorporate all those things. There is another supplementary protocols have been provided, and which allows the non-ASCII data like Hindi or any other languages, or besides the language text, the other like video or multimedia or the voice also to be sent. So these limitation has been come up in the newer protocol called in the supplementary protocol MIME, which allows the multiple files to be incorporated, multiple attachment also to be sent, and in different kind of text also it can be incorporated. So what is that addition that MIME has been has proposed? It is a multi-purpose internet mail extension which is nothing but in between the mail header and the email, which is the conventional thing. It has the additional header information has been inserted. It is named as MIME header. It defines 5 features or 5 parameters, but the initial 3 are more useful. The remaining 2 can be discarded as the optional. So first is about the MIME version. So the recipient knows which MIME version it is coming through. And then it talks about the content types. So the content types could be type of multimedia, whether it is video, voice, image, text, so like that. And then what is the type of coding? If it is not ASCII, then it has to be coded into some form. So it has been coded. So what we can see here, the sender sends non-ASCII information, and the MIME in turn converts this MIME into a 7-bit NVT ASCII. So NVT coding is a virtual terminal, network virtual terminal kind of coding. So it allows 7-bit information to be passed, and it contains the ASCII character as well as the control characters to be viewed onto the printer as well as onto the display. And it's sent across the recipient, and at the recipient, again, this MIME header is decoded, and after decoding, it utilizes the same conversion code and transfers the message into original format. So we can see the explanation of these MIME version, content type, content transfer encoding, and content ID. It uses different kinds of, so many contents are incorporated. Each has got one content ID. And also about the content description. What are the contents, whether it is audio and video, those things, information are sent. So with this brief initial description about the email traffic, we'll come to know about the packet capturing mechanism. So how do we do the packet capturing? And what is the packet capturing? So on the network, whether it is a single network to network or between the two dedicated link, hotline, user to user, we can put a tab. With the tab, we call either the sniffer or the interceptor. It can be known with the many names, packet capturing devices. So what it allows is you can see the capture without disrupting the traffic, so that the communicator doesn't know if somebody is blocking our traffic. So that is called the sniffing, without letting knows the communicating team about somebody in between. So this is the best mechanism to capture the packet. We often call it the packet sniffer. So there are plenty of sniffers implemented and openly available, open domain software tools, which allows us to watch, display, and log the traffic. And one of the good example is the void SAR. Now, the mechanism behind the packet capturing is the port mirroring. So what we do, it is basically the software oriented things, but the speed is limited. If you want to capture the large bitrate or the large data rate traffic, then one has to go with the packet splitting mechanism, which is generally hardware driven. So around the gigabits and all, we have to go for this solution. There are plenty of readily solutions are available in the market, which is being used and inserted in between the network, and it allows packet to be sniffed. So this is basically the hardware oriented, but here the software, so software overhead is put. So but the software only gives the time delay, and we may lose some packets. So that is one disadvantage in the packet mirroring, which in general applied by the WireShark and other software, open source software domain. But this dedicated hardware allows large data rate capturing. So as I mentioned, the WireShark, TCP dump, and Ethereal, these are the tools which allows the packet to be captured, and they save this packet into .pcap or .png file formats, which is commonly acceptable onto all the kinds of platform, in general Windows or the Unix. But for the Windows and Unix, there are two APIs which allows this type of packets to be captured, which is WinCap or libpcap. And these can capture in pcap or PNG, which is a new kind of packet capturing, new generation capturing mechanism. So once we capture the traffic, then one will save into certain .pcap file or the pcap ng file. Then one will be interested to know the file format structure. So every file or data file or the editing file, for example, the .pdf or .doc file, every file has its own file format. Similarly, the pcap file has the file format. So the file format generally, it records it captures the information in the chunks of records, and puts a record 1, 2, 3, and so on, so forth. And on the entire record, once we are going to save, stop the capturing and save, then it adds a global header. And in each record, there is two parts. One is called the packet header and the packet data. So the content that is being captured is kept into the packet data, and in each packet data is appended with the packet header. So the packet header and packet global header qualifiers are given into this format. So this is the global header structure. So there is a magic number, then the version of magic number. So this all things qualifies about the type of package. It gives the starting time of capture or the data links. Suppose we are capturing the Ethernet, then it mentions the Ethernet type. But in general, other things like SDLC are very common on satellite and other things. Besides, there are around 7 to 8 types of commonly data link type they are used, where the traffic is framed into a particular topic. So this information is kept here. And then it also allows to look how the bits are big endian or small endian. Those kind of information, all the information is kept into the structure, the pcap file structure. So these information I have listed here, and can be you can rush through all these things. And the important thing is the snap length. So in generally it is 65,000. That is what the length IP packet in general also incorporates. So that length has been fixed as by default. But then we can override it also. Coming to the record headers, because the global header follows by the many records. So each record has mentioned two parts. So one is the header and another is the content, actual content that is being captured or the snipped or the intercepted, whatever you can say. So this record has the 16 byte of information. This also appends the actual packet length and the packet length shape. So these two information is important, and besides the timestamp. So this will see when we show a typical packet that has been captured during the WireShark. Now coming to the frames. So as we know that when the information is sent, then at the different different layers of communication, we say there is the segment. First at the transport layer, we have the feel of the segment. And segment is packetized when it comes to the IP layer, and the packet is formed into frames at the link layer. So at the link layer, for example, the Ethernet, we have a frame which is nothing but it is the total IP packet, and it is the payload of the link layer. So this has the MAC address, MAC destination, and the MAC source address, and the type of traffic that it contains, whether in general it is the IP version 2 or IP version 4 or IP version 6, and the actual frame data. And it also follows with the frames sequences is used for the error correction and all those things. But in intra-frame, frame to frame, there are preamble and the intra-frame gaps. So at the physical layer, these preambles and all those things are used for synchronizing the bit streams. So this is how the traffic is transferred when it comes to the physical layer. So again, these parameters are important for the traffic analyst. And if the same frame is going through VLAN, then additional things, VLAN tag is added here. So you can just notice for that purposes, I have added this one. Again, this, I'm saying that now that this frame, which contains nothing, this is the IP data. So just for reference, I am giving this is the IP header, because when we give the IP packet, so in general, IP version 4 is structured like this. So we have the source address, destination address, followed by the data, and then we also give the checksum and what is the protocol which above this layer, whether the UDP or TCP. This information is put here, and then other things about the version of the protocol with the IP version 4 or 6. So all those things you know, and the total length of the header. Total length of the message information is also we can append here. Similarly, for the TCP header, because in general the TCP is used, so I have mentioned the TCP structure, packet structure. So we can just refer it. Now coming to the Wireshark, how the Wireshark is used is the traffic analyzer. It is the open source I have mentioned. It allows us to capture network traffic. It sniffs the traffic without disturbing the traffic. Decodes packet protocol using the dissectors. So dissector reads all the bits and bytes and analyzes. It defines the filters. It can filter. If you say that only certain kind of traffic can be captured, it allows that. And it displays all those informations. And then it generates all the statistics of the captured packet and analyzes it. We can save also these files, and interactively we can change in the real time also. And even the offline mode also, we can work with this. So for our purposes, we have used for the offline purposes. So the application one can see, the admin, as I have mentioned in the our motivational transparency in the beginning, it uses to troubleshoot the network, and then it examines the security problems and develop new protocols, and the internal details can be learned. So these are the applications of the PCAP on the Wireshark that can be used. Now, how the packet can be captured using the Wireshark. So once you open the Wireshark, it displays the display. It has been configured, but one can change those things. So then there are menu given at the top of the display. So the capture, you can capture the go for the capture, and then as shown here. So Wireshark capture interface, and you have to define, because network NIC cards. So at that, you can have many connections. So you identify which connection you are interested. And after defining that, it will allow you to capture. And it captures and stores it into the memory as you define through the buffer. So after it is captured and you want to see the display, it will display like this. So now it displays the packets. So as I mentioned, it displays the timestamp. So it gives in the resolution of microseconds. So it arranges like after each microsecond, the packet has been captured. And it gives the packet numbers. So for example, here it shows the 64, 65 like that. So the captured packet. And for each captured packet, it shows the source IP address it has sent from, and the destination it is destined for, and the underlying protocol that has been used, and some information it gives about that as the remark it adds, or after analysis it adds. Now, if it in generally configured in 3 pane, we can split this window into 4 also. So the default splitting is where we can see the list, packet list, and then for each packet, after clicking, we can see the packet details. So the packet details shows more about the time, about the source, destination, the protocols, and the upper protocol, those kind of things it shows. And then the third pan of the display, it shows the packet in bytes, or the so once we do that, then the other advantage here is for simulation purposes, we can also show one-sided traffic also. So we can show how the traffic is communicating between source to destination, when the source has sent and the destination has sent. So all those chronological things can also be arranged. So once we do that, then the thing is, how do we reconstruct traffic? For example, I am interested in looking at only the source and to recipient end, the email traffic. So the email traffic here, though SMTP kind of thing is not, simple mail transfer protocol will be displayed, but once we have to reconstruct the traffic, we have to go through the follow TCP string, because the underlying transport layer protocol is the TCP. So there are mechanisms to collect all those TCP traffic. So we filter all those protocol base, filter the traffic, and once all such traffics from the particular source, destination, and the pair of ports. So we define a set of tuples. So 5 tuple, for example, we set the source IP, destination IP, the source port, the destination port, and the protocol. Then such all such kind of thing, such kind of packets which is transferred and received between these two transmitter receiver will be connected at one place. So after that is collected, then we go for the follow TCP stream. So once we do that, then that will be reconstructed. So we'll come to the restriction, come to the reconstruction at the later end of the presentation. But before that, we just give a snapshot to show that we can also save these manipulated packets in our display, or we can put it into the data metadata also, or the database by exporting the comma separated value file. So CSV is the more common file format which can be used to do that. So this is a brief description about the Wireshark. And to mention that Wireshark is a powerful tool. So before formulating the methods that we generally do that analysis through the Wireshark. Now I will dwell upon some more about the traffic that we have we have found our interest and we have done. So we'll give some flavor about the communication scenario and how the communication happens, because you people are mostly from the computer science background. So it is my privilege as well as some duty also to give some brief idea how the communication network works in more detail. So let us see outwardly it appears how the satellite VSAT terminal works. See, the VSAT terminals in generally we can do the configuration in star as well as mesh connected, but the optimum solution or the cost-based solution, cost optimization solution is the star one, spoke and hub kind of network configuration. So there is a big hub, which is a large disk, and small terminals. For example, the TV that we are set box TV that we are seeing. This is also this kind of terminals because it allows the terminal to low cost terminals. It doesn't require high power because the receiving power is more. So, and the transmitter and reception power here is more. So this kind of scenario is more useful. And this is also equally useful for the defense purposes also. For example, in the defense, what happens, at the headquarters, the big hub is placed, and the portable VSAT terminals are taken at the field location. So at the LSC or LOC kind of situation, our adversaries sit with a small terminal and communicate with their master at the hub. So this is the situation. So what happens? This is called uplink and the downlink. So, or the inbound outbound. So this is the outbound and this is the inbound kind of traffic. So so how to do the interception here? Because these two channel goes over two different carriers, and these two carriers are radio frequency carriers. For this, we need a separate modulation and demodulation. So the extract, we cannot find the two-way data here. As suppose we are intercepting or sniffing the data on a LAN kind of thing, then both the packet going from receiver to sender and coming response from sender to receiver can be visible. But here, these are at the two different links, maybe at two different frequency. So it is not possible to see. So we have generally one side traffic. And looking at the one side traffic, one has to estimate, judge, and identify and extract the intelligence. So this is the challenge that faces in the radio frequency when we are intercepting, besides the wireless. So now looking at the internals of the communication terminal, what happens? We see that this is the hub and this is the BSAT terminals. In between, okay, this is the noise which is added. And one, I just want to remind that this is just nothing but it doesn't do any processing. It is just a reflector. It simply reflects whatever coming to this, it reflects to the receiver. And from here, whichever comes, it reflects to the hub. So this is the configuration. And it can also add the noise. So what we do in generally, in communication, there is a transmitter and there is a receiver. So now the transmitter, whatever information you have, you encode it. For example, we have encoded in the ASCII format. So ASCII information, you encode it. And then, so this is the purpose of the source encoder. And if it is, suppose the encoder is ASCII, beside ASCII, it is voice, then what we do? Then we reduce the bandwidth. So compression is also takes place. So the source encoder is nothing but it encodes, it compresses all these things. And this lies at the application domain and remaining thing at the physical layer domain. So we can see that in the classical communications, we have only two layers available at the application and on the physical layer. And the remaining thing, channel encoding, because you have to combat the noise. So what you do, you do the channel encode, error correcting ports and all those things. Then we do the scrambling, de-scrambling. Then since you have to send across at the long distance, you modulate the signals. At the receiver, we demodulate it. And if you want to tap here in between, for example, here the interceptor is sitting and it is sitting in between. The carrier is going and coming. So you are intercepting here. That means somewhere in between here. So we have to do the demodulation, then the channel decoding, error decoding, all those things. And then you come to the source decoding and you find out the voice or those information. In between here, one can add the encryptor, and at this point it will be decryptor. So this is the common model which is used. Now we can see at the layered format. So earlier there was only two layers, this and this. Now as convergence is taking place. So what is the meaning of convergence? Convergence is sorry. Convergence, the TCP/IP protocol suite is the main motivator of the convergence. Before that, all the networks are distinct and different. They cannot communicate each other. For example, the satellite cannot communicate with the GSM or the mobile communication or the landline. So these are the difference. They have to their own transmitter and receiver. But the TCP/IP has allowed the intra-communication between different kind of networks. So it has added wireless, plain old telephone, then optical fiber, terrestrial link, which was earlier E1, T1 or a TDM kind of application, mobile, which uses the GSM, then the satellite, which generally uses Aloha kind of or the Aloha kind of protocols, and then the TV, which is uses broadcast, and the fiber OFC cable, which uses ATM kind of network. Everything has been integrated, is possible to integrate and being integrated by expanding the application layer and computer transport layer on other layers. So in satellite also, you can, I just show these glimpses that now you only have this is a satellite dependent layer, and the remaining is the same layer which is used in other conventional. Only thing is we have to use an adapter, satellite adaptation functions. So we can do that. Now, if we see that how this layer goes, then I'm giving just the satellite because it uses, if you are using the voice, then it uses TDM. If you are using video, then you are using MFTDMA, time division multiplex with multi-frequency techniques, and then SCPC. So these are few common terminology that is used. Single carrier per channel kind of things were used in satellite. And this all these things, physical layer happens that I have shown in the communication model, demultiplexing, FEC decoding, de-scrambling, de-interleaving, and demodulation, all happens here. Then we have added all these things. So now it can communicate with the SDLC protocol. We can go to the IP. You can use IPsec, then use TCP/IP, UDP, all those things. Add the security, and then communicate with whatever services or the protocol, and then you do the digital video broadcasting over TCP, VSAT communications, even fixed satellite services like TV and broadcasting that you can do. So all these things can be done by adding these things. Okay, so one example I will just show the how the IP is communicated in the remote area. So for example, suppose our fellow citizens sitting at the Andaman kind of isolated place. Earlier there was no marine fiber cable. Now it has been laid. So it was being done through the TV. So what happens? The users have the digital video broadcast return channel through satellite terminal. So DVB RCS, digital video broadcast with return channel through satellite terminals. So these are the technology is used. So what happens? The hub, it broadcasts for all the terminals. So it broadcasts for all this. So they have respective IP packets, and they use their IP packets and receive those packets. And when transmitting to the hub or the other, the main so they will transmit through the low bandwidth signal, and this is being collected. All this low bandwidth signal is collected by the hub, and they are assimilated, and sent to the respective recipients. So this is how the internet or the video is received through the DVB broadcasting, and it is becoming a very useful tool. So lot of traffic is sent through DVB IP traffic. So in defense particularly, this has become the vehicle for transmitting the IP traffic through video broadcasting, because as I mentioned that for the strategic application, this VSAT, a small terminal satellite, small satellite terminal are becoming very potent threat or use. So it generally happens the video, audio, and the IP data are encapsulated, and they are put it into the MPEG transport stream. MPEG is a video broadcasting. You have to picture expert group, moving picture expert group. It is there, so it does the encoding of the video data, and it is put into the transport stream. So this transport stream comprises of generally 188 bytes and is 4-byte header and the remaining 184-byte payloads. So these payloads, you can add everything, IP, video, audio. So when it goes at the receiver, so individual receiver identifies its IP packet and extract those information. And using these techniques, they can communicate. Now, once you capture the traffic, then what is it? Suppose you are unidentified things, because you are the passive receptor. So you don't know about the type of traffic. So one has to do the analysis through the network kind of. So what is the IP, or what are the protocol at the network layer being used? Similarly, at the transport protocol layer used to the ports and all those things. So you keep record of those things, and then you also identify the application. The other method could be to identify, suppose the video is being transmitted and you don't know about the content, or you don't know how to, because you are not the legitimate decoder of the transport stream, then how will you know? So the stream of data that will come has a large bulk of data. So the transfer, by looking at the volume of transmission, you can cluster those kind of traffic and try to identify. And then you have to find out the ways to how to segregate them into different kind, whether it is through the packet, whether it is the web page, or the traffic it is pertaining to the game, or point to point, something like that. So all these things, for them, you have to develop their own technology if you are a passive interceptor. So just to give the glimpses of, we have just mentioned all those things. Now, coming to the male and female analysis that we generally try to do. So how we go about this, female or female? So, can we break for 2-3 minutes if you are not bored? Dr. Gambhir. Am I audible?
Sir, yes, sir.
So before I go to the next transparency, just can have a 2-3 minutes of break, then we'll join. Can have water, or if you stay, just will allow me to have a sip of water.
Of course, sir.
Or any question you would like to ask, which can I clarify? Sir.
Sir, is the Wireshark free? Wireshark.
Wireshark.
Yeah. Is it the free?
Bit louder, sir. Wireshark, which is the field?
Oh, just a minute, sir. I think I have to put the speaker. Yes, sir.
Go to the Wireshark.
Yeah. I said, is it a free software or not? I mean,
Yes,
how
sir. It is free software.
Wireshark.
Wireshark is completely free. You can download and you can do all the analysis,
Okay.
and it is completely free. So this is complete open source tool, and it is free. It will give you all these things.
Can we also analyze the messages, each message, what content going in this?
Yes, yes, definitely. Because once we see, this is the packet bytes, the content.
Okay.
So in fact, this is the content. This is about the packets. It gives the number of packets or that you have, and in the real time also you can view. And in the real time also you highlight particular, we can see the content. Even it is passing through, it will hold to a particular packet and allow you to have the look. So in real time, it
If
gives.
it is not encrypted, then it can be understood.
See, if it is encrypted, then it will mention in here in this description that it is encrypted, and it will mention that it is a SSL or TSL. Below that, you will not be able to see.
Mm-hmm. Fine. Thank you, sir.
So this, because that is the limitation of every, even we, with hard effort, we also cannot see that.
Yes, sir. Okay. Thank you. Anybody want to ask anything? Anyone? Any participant to ask? Okay, sir. Good to go.
So I have half an hour more, I believe.
Yes, sir. You can take
Okay.
more time.
Oh, no, that is sufficient time for me. I may not take more than that. Like, if some discussion required, I can go ahead.
Okay,
So, see, now to mention about some of the tasks that we have been carrying. So, what we have been carrying is we are taking the traffic, doing the demodulation, decoding, all those things. So all these things pertain to the electronically finding and decoding at the physical layer. So after the physical layer is removed, all those things, demodulation, error correction, the synchronization, all those things are removed through some codes or through some in-house developed hardwares, because that is done hardware, because the traffic that you are receiving at the is more than Gbps rate, more few Gbps rate, gigabits per second. So after that stream is coming, we capture those one-way traffic. As I mentioned, it is one-way traffic. So only either the receiver is sending to the transmitter or transmitter is sending to the receiver. So that traffic we get. So that stream comprises of mail packets or the web page packets or different kind of packet, even the chat, messenger, all those things it have. And it also to be mentioned that the satellite, you can say that now why not everything is encrypted? We have done these things for the plane because the satellite infrastructure is generally deployed for 15 years, not less than 15 years. Then only the cost break even happens for commercial purposes. So that has to remain for 15 years. So suppose some 15 years back, that infrastructure has been created. If it is created in plane, then it will still continue to use the same kind of configuration. So we are still able to see some plane information. But here in this presentation, I will not use those kind of classified traffic that we have doing. So we'll only give the snapshot of traffic that we have found on the open source domain. You can also find this in the open source. There are old some old traffic there in some repository. You can also find, and then we can also simulate one-way traffic through the WIRESAR. So these are the techniques that where we can validate your algorithms or your methodology. So this is how we have also gone through. So now coming at particularly to the email. As I mentioned, when we get the web page, for example, so the web page that we see when we are seeing the two-way traffic, we get many kinds of objects on our web page. So the image, the HTML code, all those things come. But when we intercept and reconstruct yourself, then you cannot reconstruct the entire thing, because the linkages between these two is missing, because each session that we create is distinct for us. So the linking of the session becomes very difficult unless we have the response side traffic also. So these challenges one has to see, and then still we can reconstruct the partial web pages. But in email, generally what happens, the email size is not very large. So 65,000 bytes in general are quite sufficient for the emails, particularly to the infrastructure that is put into the satellite. That it doesn't use more than that. We generally have not come across more than one or two attachment. That two attachment is not the large attachments. So the size is very small. So one session of capture is sufficient, and we can do that. So that is the advantage that we had, though one way, but one session is sufficient for us. So we could able to do some good analysis. So here I will just go through how we look into the email traffic. And so email traffic, we look for all those things. So once we have demodulated, then we see that what is the link layer. This information, the moment we feed this offline, see, after capturing the demodulation decoding, we record generally, because the high-speed data cannot be straight away fed to the WIRESAR. So we generally record 3 GB, 4 GB. And then 3 GB, 4 GB traffic, we break it into a smaller size. And then we feed this PCAP to the WIRESAR. Or we have developed tools using TSARC. Again, TSARC is the another tool that the same fraternity has developed. The WIRESARC generally gives like a oscilloscope display. You can see the display, but you cannot capture the data. But the code involved in underlying in between. But the TSARC, it allows through Python script, we can use the TSARC code of the same fraternity. There is a big library developed. So you can exploit those things. And that is what exactly we have also done. We have used the library through Python scripting and the TSARC library, those smaller code, we have applied and have done the all those things that is visible through the WIRESAR. So remember, TSARC is this does similar kind of analysis work. But the TSARC gives, or the WIRESAR gives the information about the link layer, and at the link layer, after the link layer in the framework, we can also know about the MAC addresses, then IP addresses, everything we know. So using these information help us to identify, as I shown the VSAT structure, where the hub is located, or where the small terminal is located. If certain thing is open, if it is not, it is public. If it is private, then no, we cannot identify the IP location. But so everything we can identify as it is available through the header information. Now, so we have done two kind of the email and webmail. So there are certain difference between email and mail. You know about those things. And this is the typical WhatsApp capture will show about. So you can see that the TCP packet that we have captured, and for the mail, and HTTP for the webmail. So again the same thing that I have described, the source, destination, IP, those things. So the flow diagram is we feed this thing, then look for the port, do the port-based filtering, and collect all those packets, and do the header identification, see the type of content, and do this thing yourself, because you have to find out what are the MIME information, because you have intercepted in between. So you have to identify everything yourself. And then you have to decode by looking at what is the MIME header information. So by doing all those things, we'll be able to recover the attachment as well as the metadata information. And same thing it goes for the webmail. Only thing is it comes from different ports. So again, the same thing, and we are looking for the mail structure passively. So how we are doing this? So first we do protocol-based filtering. So either you go for the HTTP or you go for the TCP base. So after doing these things, you collect the similar kind of traffic, and then we do the follow TCP stream. So doing the follow TCP stream, you will be able to see the traffic. Now this traffic, you can see, this is the email header portion, this is the MIME header, and this is the message body. So now you have to look for the 5 important important field into the MIME header, and then if there is attachment, and look for all those things. If the information is in plain or encoded, you do the reverse things. For example, in this message, the traffic has been completed by follow TCP stream. That means all the packets between one particular source to another for the one particular socket. That means 5 tuples. So IP, source receiver, and then port, source and receiver, and the protocol. So this one, based on 5 tuples, collect all the similar traffic, and then do the follow TCP stream. The output will be look like this. So in this output, this is the mail header, this is the MIME header, and this is the information and the attachment. Okay, so I will show this attachment is, look for this. So the content is displayed here, and some geolocation information has been sent as an image. And for this image, it has given the content transfer coding is base 64. So we collect this thing manually. But if you use the T-SARP, this information you can capture. This information you can capture and apply the base 64 decoding, and this will convert and give it to this type of attachment. In manual mode, you can you can do that, then it is good. Otherwise, in the Wireshark is automatically this is not possible. So you have to contented with that. For you have to add this extra. Similarly, for the webmail, you can see that we have been able to identify that it is coming from the webmail AOL. Otherwise, many times we are not able to identify the AOL. But fortunately, this is the open source traffic. that available on this thing. So we could identify the webmail, and then in the webmail we identify that this is the, in the data portion, that this is the JPEG image. And after finding the JPEG image and the location, we are able to decode it. So this has again been done either manually or through the TSAR coding or Python coding separately. So once we do all the collect all pertaining to mail information. Now I'm talking of only for the mail information, because we want to put it into the database. So because ultimately we are trying to do the analysis. So all the mail information you collect and put it into one kind of table. So source, destination, and then if you can extract the subject, if it has the attachment or not attachment, so like that you prepare. And prepare and see that this particular information has this kind of, this is the traffic which has the content like this, and it has the attachment like this, as I mentioned earlier. Similarly, because now we have to do some statistical analysis. So you know that it is coming from the protocols. So this is for, in general, when we capture the traffic, because at the beginning also we have to identify whether the pages has come, what are the protocols has been used. So to begin at the initial stage, when we have not identified or we have collected the only IP, so we have to do the statistic of the all mixed traffic. So these are the statistics. For the IP also, suppose in the previous example, if it is coming, we can do this statistic from the same IP, because in the law-abiding agencies or the intelligence agencies are interested in looking at the source IP and destination IP, how many times or what is the frequency of their communications. So you can generate such a statistic. If they are communicating very frequently, then the suspicious lies on them. So such kind of a statistic can be done. So I have seen, I have just displayed for that purposes. And then also we can identify the geolocation. So geomap you can create. So for our purposes, we have plotted into the world map. One can do at the local map also, that from where to where it is being communicated, and the location of IP can be identified if it is not private. If it is public, one can identify. So these are the things one can do using the mail identification, traffic analysis. Now coming something about the email security. So as we know that there are two kinds of popular protocol, MIME, SMIME and PGP. PGP, coming to the SMIME, multi-purpose internet mail extension, earlier MIME is being used that we have discussed. Now we add certain security features into that, so it becomes SMIME. So it will, so that it has plain, encrypted through 4 types of mode of operations. So we'll come into the subsequent transparencies. And what it generally does, it does the authentication, integrity, and the confidentiality kinds of services it provides. And similarly, the PGP is a pretty good protocol. It was invented by Phil Zimmerman single-handedly, and he later became the billionaire by inventing these things. Earlier, he was for some time he was put under the observation also, or put behind the bar also, because he gave this as a open source domain tool, but during those times the encryption or decryption things were not for the purpose of export and for the open use. So what he did is he simply published a book and giving all the information, all the coding information into the book. But the book could be published. So later in the court give him the go ahead, and he was left. So that is the some history about this PGP protocol. But it became very popular, and it also gives the authenticity, data integrity, confidentiality kind of things. And later on, the MIME becomes popular because it could be used for enterprise or the bigger organization. But for personal use, still PGP or the open PGP is very popular. So how the MIME has been implemented? See, MIME works in three modes. It is the clear mode. One is clear mode that we have discussed, the plain things, as already we have discussed how the mail goes. Then another mode is the signed mode. So clear mode I have not shown. Another is the signed mode. The second one is the encrypted mode. And fourth is signed and encrypted. So we can see that if it is signed, then its a signature symbol is here. And then if it is encrypted, then a lock sign is here. If it is signed and encrypted, we have both the round here and the lock here. So how it happens? So the information by the sender, it in conjunction with the certification authority. So see the certification authority in the behind. So in conjunction with the certification authority, gets some certificates for signing. So the plain information is signed. So only the information is plain, but signature is signed. But the signing has to be verified. So the recipients receive this, and it verifies this thing by interacting with this authority. And after verification, the information is authenticated. Yes, you are the correct sender. So this is how this mode works. Then the encrypted mail. So in encrypted, the encrypted information comes like this. The mail comes here. It is encrypted by some session key. The session key, so it is encrypted, goes here, then it has to be decrypted. For the decryption, it has to be verified with the private key. So again, for this private key, it has to interact with the CA, certifying authority. And then by certifying authority, because the key is also encrypted, because the session key is encrypted. So session key is encrypted with the RSA. So the RSA private key uses here, and then the traffic is decrypted after extraction of the key, and then you get the information. In the signed and encrypted, the signature happens, and then encryption also happens, and both the things is sent. So at the receiver, the decryption happens, and after decryption, after the decryption, this again the signature is verified. So this is how the three mode works. You can just go ahead for the detail. You can. I have just given some brief description. And for the PGP implementation, though this is only I have shown the encryption and decryption. Authentication and the authentication has not been incorporated here. So let's say this is the data, and it has to be encrypted. So some random number generation is being done, and the key is generated. This key, using this key, the information is encrypted, and the encryption indication is given here. Now, the encryption key is also to be sent to the recipient. So this is concatenated and sent. Now at the receiver, the encrypted message is received. Encrypted message, and you extract the encryption key, which is of course through the RSA. So the encryption key is extracted from the private key, and then using this extracted key, you decrypt the information. So this is how it works. So I have listed some comparison here. So it both provides the confidentiality, authenticity, data integrity, and in both the things. Particularly the difference, it doesn't do any compression, but here the compression happens. Then the certification is slightly different. Here the security of the CA infrastructure is used because there is a third party involved in here. But here there is no third party involvement. That's why it became very popular, and it is used for the personal purposes. So this is the main advantage of the PG. Now, when we talk of the authentication, then all the authentication load lies on this server. So how the server, there are three kind of element for doing the authentication. There is called SPF, DKIM, and DMARC. So three things. So SPF is the sender policy framework. So the purpose is the domain owner can identify. So one has to ascertain that the IP address is correct, because it is not coming from somebody spoofed IP. For example, if I use gmail.com, then the Gmail IP addresses of the Gmail should be trusted. So that this thing comes under the sender policy framework. Then domain key identification. It relies on a unique signature to verify the sender. Then whether I am the legitimate person to send or not. So this is configured through the domain key identification. And then the DMARC is the policy implementation. Given the SPF and the DKIM, how these things can be implemented. Means how the action is taken at the server. Whether whether it is to declare it is a spam, or reject it, drop it, or return it, or do nothing, simply leave it. So these things are defined in this policy, DMARC policy. So this is very important. And now I have given just a schematic diagram how it works. See, the information by sender implements the signature, and the message is like this. So message with signature. So this comes under SPF. And then the server, our server, which MTA, message transfer agent, adds a certain DKIM signature with the verification of the sender DNS. It connects with the sender DNS and puts a tag here using certain signature key. So we're using these two information, header and trailer on the message. This goes over the network. So at the recipient, at the receiver end, this has to be authenticated. So the receiver message transfer agent, sender and receiver message transfer agent, communicates with the sender DNS and verifies about these two things. So about the SPF and about the DKIM. Now for the third thing, it has to take their own policy actions. Besides this, because this transmission goes over the secured layer, the TLS and all those things, so those keys are also exchanged. So for this, this block is shown. Now, there has been some, I will give some report based on the, it has come some report by the World Health Organization, I will discuss at the last, that this policy making, if it is weak, then some compromise can be done. So what could be the vulnerabilities in the email? Email data particularly, like any other traffic, the malware, spam, phishing, social engineering, ransomware, these are the typical things that we encounter in the email. So, okay, so I will not go much about this thing. To mention that say where the attacks is possible, and see there are sometimes called the security track, CIA track, confidentiality, integrity, and availability. So you can read availability, authenticity also. But in general, CIA tracks called availability, means denial of service attack. So if availability is not there, means denial of service attack on happens. And then confidentiality about that it is encrypted or not. So somebody is looking at this email. Somebody can look at the mail. So this comes under confidentiality. So one can attack on the confidentiality. One can attack on the integrity, means he keeps this packet and exchange this packet with the other packet, or the man in the middle attack. So these are the kind of integrity attack. And then the authenticity attack. So somebody is spoofing, or somebody is masquerading, impersonating. Those kinds of things comes under authenticity attack. So the this thing, in this paradigm, one can discuss the attacks. So the mail can be spoofed by showing that one can register, forming the malicious email, and send through the SMTP, and find the vulnerabilities at the DNS, or tampering the records. So you can yourself go ahead with this, because I am crossing my assigned time. So I will end my discussion with some the thing that I was discussing during the COVID time. So COVID time, what happens now? On the name of World Health Organization, somewhere the donation was asked. So this was what in the spoofed in the DMRC policy weakness. So because the WHO didn't have the strong or very strong DMRC policy. So what happened now? What happened? Though SPF and DKM was there, but no DMRC record for WHO.int. What to take with this? So this domain was created, and with this domain, this thing was asked, donation was asked. But after that incidents, it was blocked. So you can read this interesting incidents. There are some references that I have collected, all mainly for the forensic related of the mail and the WhatsApp. All those things you can see on the mail also. If I can answer some question, I will be glad. Thank you.
Anyone from the participant want to ask any question from sir? Anyone from you?
Sir, I have one question. Can I ask?
Yes, sir, sure.
Sir, you were talking about this satellite thing, that is DVB RCST. And so you were saying these are low bandwidth things which are coming from, say, Andaman, Nicobar, or other places.
Yes.
So is this same as single channel per carrier, or this is some different technology?
So this is different technology. Single SCPC is end-to-end broadband connectivity. Suppose if there are hundreds of, and this is basically works on TDM. E1, T1 carrier is bunched, and then it has to be sent. So big hub to big hub. It is big hub to big hub, and it is TDM kind of things. So that is under SCPC. But this one is the can I come to the transparency? This one is the what happens now, the transmitting terminal have the, because I am the single user, I want to see my mail, for example. I want to see my mail, then my bandwidth will be very less. So, so my bandwidth will be very less. So what happens now? So this receiver, this goes through the time division multiply. Same carrier spools over many users in time division mode. But this is broadcast. So this contains the information about the traffic about this one also, this one also, this one also. It is multiplexed together. So if this individual extract its own packet by correlating those information. But when this returns, this is a small bandwidth, because if I am interacting, my bandwidth is very small. But in SCPC, both the side bandwidth is very much. So this is the difference.
Thank you very much, sir. And second thing is, you talked about that steganography plus cryptography in an email. You showed a picture of some lady, and you said there is a small email into that. So can you please show that slide again?
It's not the steganography thing. We extracted the attachment, because the attachment here, it talks about the image JPEG. And the image JPEG, the information was there somewhere, but the coding information we could not extract. Though it is called the webmail, but the webmail goes under what kind of coding? Because see, we can see the MIME information only if it is through the SMTP. If it is through HTTP, then we cannot do. So what we have to do, we have to interpolate or extrapolate. So by looking at that, this content is something as the image JPEG. So we try to collect those portion of bits and then try to open those information with the JPEG editor or the some viewer. So we could able to see that, luckily.
No, I mean, what you are saying is the picture is being sent. This type of picture is sent.
Attachment, as an attachment.
Right. Okay.
But
then
the coding information we are not able to see. But it does
I see.
say that this
I
is
see.
JPEG. So we have to do all hits and error and trial and error methods. With the JPEG, how can we open this? So these things one has to attempt.
I see. Thank you very much, sir. Thanks a lot.
Thank you, sir. Anybody else want to ask anything? Anyone else from the participant want to ask any question, any query? I think, sir, there is no queries.
Thank you very much. But
everyone understood a very good way.
Good learning for me also, because
sir, you explained in such a good way. Everyone understood everything.
That is one way, or it has passed over everybody.
सर आपका ईमेल बाद में शेयर कर देंगे ना सर, इनके साथ, मैडम के साथ में, तो फिर
हाँ, दीपक सर आप शेयर कर दीजिएगा प्रकाश जी के साथ.
ठीक है. थैंक यू वेरी मच.
सर आपको दीपक सर शेयर कर देंगे आपको प्रकाश जी.
थैंक यू वेरी मच.
Sir, please stop your screen sharing. I want to share something for you. Devendra sir, आपके लिए.
Stop sharing screen. Okay.
Yeah.
How to do that? I have to learn.
The green button at the bottom. The same thing, green button at the bottom.
Sir, at the top of the bottom, at the top of the screen, you will get there the stop sharing.
Yes,
yeah.
Sir.
Now it is fine.
Okay.
Sir, this is just a token of thank you from our department of IT from Galgotias College of Engineering and Technology. Thank you, sir, for giving your valuable time and such a nice session, very informative session. Deepak sir, you want to say something? Deepak sir?
Okay, hope it would serve some purpose.
Okay, sir. Thank you,
Generally,
sir.
we learn
Thank
the
you.
things in a, hello. I
Hello.
said generally we learn things theoretically, but sir had made us to learn the things practically.
Yeah,
How the things are going practically, and how to segregate the emails. So that's quite interesting, sir. Very thank you.
very informative.
No, sir.
Really.
What we do is also. So if you, some of your students are interested, can come at trainees and do certain things. Doing these things.
Definitely, sir. Definitely.
Somebody is interested, but this is electronics and communication as well as the computer
So
science.
now
Because see,
nowadays
everything
everything
is
is
now,
interdisciplinary.
exactly. So one has to be open.
Yeah, yes, sir.
At the back end of the career, I have to learn the computer science.
Definitely, sir.
Thank you.
Thank you.
Okay, sir.
Thank you, sir. Thank you so
For
much,
giving
sir.
the opportunity.
Thank you. So we will join again at 12 p.m. For the next session of Dr. Rajesh Mehta.
This is small tea break for all of you. Again, we will be joining at 12 p.m. with so who is the next speaker?
Dr. Rajesh Mehta from Thapar University.
Acha,
He
Dr.
will take
Rajesh
us
Mehta
very
from Thapar University.
practical. Very
Okay,
interesting
okay.
session.
Okay, so see you soon again with all at 12
Thank
p.m.
you. Thank you.